In this investigation, we generalized our reasoning about linear relationships to generate the general linear function formula. And this says that if x and y vary together at a constant rate of change, and the constant rate of change of y with respect to x is m, and y equals y1 when x equals x1, then y is equal to m times x minus x1 plus y1. And this formula expresses y in terms of x. Now each part of this formula has a special meaning. So we'll draw a graph to keep track of our quantities. So we know that when x equals x1, then y is equal to y1. So we can place a reference point, x1, y1, on our graph. Now if we pick any value of x, so if we imagine any value of x, then we can imagine x changing from x1 to the current value of x. And this change in x is equal to, x minus x1. So x minus x1 represents the change in x from x1 to its current value. Now, to compute the corresponding change in y, so y changes by some amount, and this change in y is m times as large as the change in x. So this change in y is equal to m times x minus x1. So if we multiply x minus x1 by m, we get the change in y. Now if we take our change in y, so our change in y is about this much. If we take our change in y and we add it to our initial value of y, we get our new value of y at this new value of x. So when we add the change in y to the initial value of y, we get the new value of y, which tells us that y is equal to m times x minus x1 plus y1. Now, if we imagine doing this, we can do this for any value of x, and if we imagine x varying while we trace the point xy, the resulting graph will be a line. So the graph of y in terms of x will be a line. And this is because the change in y is always m times as large as the change in x. So because the changes in x and y are proportional, the graph of this relationship ends up being a line. So just like the graph, the formula represents all corresponding pairs of x and y. Now, in the next investigation, we'll continue practicing this reasoning and using this new formula, as well as look at some special cases of linear relationships.